Okay, so just as we were all waiting for when is the Gemini 2.0 Pro going to go GA or generally accessible, Google has turned around and released a Gemini 2.5 Pro. And in this video, I'm going to go through what are the key differences. There are a number of really interesting differences in here. We'll have a look at how you can get started using it. And we'll also look at what this actually means for the Gemini family of models. One of the things that the Gemini team has really benefited from is AI Studio, where they've been able to release a lot of these experimental models. Now, Gemini 2.50 Pro is an experimental model, just like the 2.0 Pro that it replaces. But this ability that the Gemini team has been able to leverage of putting out these experimental models, getting a lot of feedback, and then iterating very fast has really enabled them to improve the models and improve the quality of everything that we've seen in here. So we saw this a lot with the original Flash thinking model that came out in December and then got a substantial bump in January where they updated it after seeing how people were using it and perhaps seeing where it was strong, where it was weak, etc. And this iteration didn't just start with the 2.0 models. Google's actually been doing this with a bunch of the previous Gemini models that were the 1.0, the 1.5, etc. And this has led us to today where they're announcing the 2.5 family of models. And specifically, they're bringing out the 2.5 Pro as one of these experimental models so that we can actually start using this model for a variety of different tasks, even if perhaps not yet in production. Okay, so what makes this model different? So they talk about the 2.5 models as going to be thinking models. And surprisingly, they're talking about that they're going to be building these thinking capabilities directly into all of the models, which to me is actually a little bit of a surprise because sometimes you perhaps don't want these models that are going to be thinking and taking a lot longer. You do want the really quick Flash models, the flashlights that can be used for just very quick tasks. So either Google's going to be working out a way to do the inference much quicker, so that's not going to be an issue, or perhaps we are going to still have the 2.0 models that we can use for that kind of thing. Okay, so why the bump to 2.5? So in the blog post that they've released, they talk about that they've achieved a new level of performance by combining a significantly enhanced base model with improved post-training. So the post-training, I think in many ways, we can kind of guess that that's a lot of the new techniques for reinforcement learning, whether it be verified reward reinforcement learning or with a reward model. That definitely seems like this is one of the key ways that people are improving these models a lot now to basically give us sort of longer thinking, meaning longer and varied chain of thoughts in getting to the actual right output that we want in here. But I think one of the key things here that's actually prompting this bump to 2.5 is this new enhanced base model. So it does look like the Gemini team have actually substantially improved how they're doing not just the post-training to get the reasoning, but also the pre-training to get the model ready for that kind of post-training. And if I had to make a wild guess, I definitely think this is largely supported by them using synthetic data, not just in the post-training, but also in the pre-training as well. Not just synthetic data alone, but combining it with better filtering and stuff like that. We saw that actually in the Gemma 3 tech report was this discussion of getting better at actually filtering the data for doing pre-training. And you can bet that if they're doing it for the open weights models like Gemma, certainly these ideas are being applied to Gemini as well. Now, it is nice to see in here that they've actually got a sort of definition of reasoning, that they're talking about this is the ability to analyze information, draw logical conclusions, incorporate context and nuance. Now, the nuance I think is kind of interesting. All the prompts that people are using to trick these models usually have a lot to do with nuance and basically reading or interpreting the prompt in a certain way. All right, so if we come and look at the benchmarks, I'm not going to spend much time on the benchmarks, but we can see that this model is outperforming a lot of the different models that are out there. Now, they're comparing to GPT 4.5, which I think is a little bit unfair because that's clearly not a reasoning model. Comparing to O3 Mini makes sense. Comparing to the Claude 3.7 thinking model makes sense. And we can see that on most of these, they're doing substantially better than the models that are out there. The only ones where they're being beaten really is actually ones where people have sampled out multiple versions and then used sort of a majority voting or something like that to actually get this out. But you can see even then, the just single attempts, so just zero shot prompting, is getting scores that is on par from multiple attempts from other models like the Claude 3.7 Sonnet and the Grok 3 Beta, etc. So in the blog, they talk about the enhanced reasoning. They talk about how it's basically doing this without the need for the test time techniques like majority voting. So that's quite simple. What you do is you basically just sample out, say, 64 examples, and then you go with what was the most common example in like a majority voting ensemble style. Now, out of the benchmarks, the one that is the most interesting for me is not things like the mathematics or the GPQA, both which are very impressive, but is this humanities last exam benchmark. So I'm kind of chuckling because remember when this came out, they made a big point that almost no model could score over a few percent on this. And sure enough, when you give these frontier labs a target, you're basically telling them, okay, optimize your models to do this. And sure enough, we've seen the OpenAI O3 Mini do really well. And now the Gemini 2.5 Pro passed that. And we're getting close to 19% already on something that was supposed to be the last exam, which I'm guessing is not going to be the last exam or benchmark that we're going to see for these models. So obviously one of the big things that people want out of these models now is coding and using the models for coding. And there's some really nice examples that Google's basically released of showing this doing things like a pixel runner game, like a number of these things where they're using the P5.js library to be able to build little games and stuff like that. Also some really nice examples of it being able to use the thinking mode to actually create code to do analysis of data and a number of things like that. All right, let's jump in and have a play with the model, have a quick look at what it can do. And then I'm going to point out one of the biggest downsides of this model in its current form that hopefully Google's going to fix when it goes to GA. Okay, so the first place that you can try this out actually is in the Gemini app. So if you've got Gemini Advanced, you can use the 2.50 experimental model straight away in here. And just to sort of show you some of the nice features that are in here. So just asked it to basically build me a working game of Tetris here. And you can see that sure enough, it's made the code, and we'll look at the code in a second. But to get there, look at all the thinking that it's actually done here. So it's gone through and basically done a bunch of thinking and reasoning about the prompt, even though the prompt was so small. So one of the things that we're seeing with these reasoning models is that it almost does a prompt enhancing from whatever you put in to actually work out what would be the best result back. And then we can see as it's going through this chain of thought, it's deciding, okay, what it's going to call the various variables, what functions it needs to have. And it goes right through that where it's going to basically need a game loop, that it's going to be using Pygame, etc., what it needs to draw. Each of these things, it's gone through 10 different things in this before it then goes to starting generating the actual answer out. So this is all the reasoning tokens or the thought tokens that are there. And then we can see it's able to use that to basically generate this code out. And it's not a long amount of code, but it's a decent amount of code here. It then gives us instructions of how to save this, and it gives us the controls, it gives us the features, etc. Now, one of the things that's really cool that they've added in here is that unfortunately at the moment we can't use it with the canvas or anything to do it locally, but what we can do is come over here to share and export, and we can actually export it to Replit. Here you can see I've exported this code to Replit without having to set up an environment or anything here. I can come in here, run the code, and you'll see that sure enough, it starts running, and I've got, this is running obviously with Pygame. And if I basically press a key to play, I've got Tetris. And you can see that I can speed things up. I can basically play the game just like I would want to in here. Now, you can see that when the game is over, so let's just score something so you can see that we can score. But when the game is over, this whole game loop is able to reset and have a screen showing that I lost and then go back to the start. So this is one of the things where a lot of these sort of game things fell down before, was that you would be able to do something from the game, but then it would crash when you got to the end or something like that. So I think this ability to export to Replit and try things out is actually a really nice kind of feature that they've put into the Gemini app. And up until recently, the Gemini app has been sort of behind on a lot of these things. All right, now the main place that most of us are going to first try this out is going to be in the AI Studio. And you can see, sure enough, if we come into the AI Studio now, we can basically come over here and select the Gemini 2.5 Pro. Okay, so here you can see I'm putting in a map. Actually, it's a map of Las Vegas. And I'm basically asking it, tell me about this location. And is Google running events there starting the 9th of April? So I've turned on grounding with search as well in here. And we're going to basically just run this. It's going to need to sort of work out, okay, what are we actually talking about that we've just given it this map? And then how does this relate to the question that I've asked in here? So you can see that it's basically taking quite a bit of thinking as it's going through this. And if we look at those thoughts, we can see that, okay, what has it actually done? It's got to analyze the image first. So it's worked out that it is actually Las Vegas. It's basically picked up some of the locations, being the airport, being the Mandalay Bay, being different hotels and stuff there. Then it's basically worked out some search queries to actually sort of run this. And then it's worked out that, okay, really what I asked about was Google events. And now I didn't say Las Vegas. Remember, I've just basically said, hey, tell me about this location. Is Google running events there? It's worked out that, okay, it should search Google Events Las Vegas. So it's analyzed that image. It's come back with Google Cloud Next dates, locations. You can see it's basically put all of that together, synthesized those search results, structured an answer, and then given us back an answer, which in this case is totally correct, that Google is holding a major event in this area around that time. The event is going to be Google Cloud Next. It's scheduled for April 9th to 11th. We've got a whole bunch of different citations and stuff like that. It's got where the event's going to be, and it can actually see that is in the image. So it has no problem of basically just taking this image here and a very sort of vague query about it and working out and being able to synthesize all that information through its chain of thought and then adding in search queries to be able to do this. And I think this is the power of these sort of multi-step reasoning models of where it's going through each of the steps, right? Up until now with models like this, we've basically had to do it in an agentic way where we would have one step that basically looks at what the map is, one step that does the searches and stuff like that. When we're combining a really strong model like the Gemini 2.5 Pro with the search things, we're able to get this sort of stuff out. So sure enough, yes, this is for Google Cloud Next. I'm going to be there. I'd love to catch up with people. If other people are going to be there, let me know. I'll certainly be at some of the events that are going on there, and we'll probably be making a number of videos from there as well. Okay, so the next query, just to sort of look at the thinking, is one that I've asked a lot of the reasoning models, is to basically explain what would have happened in World War II if nuclear weapons hadn't been used. So I'm kind of curious to see what it's going to give us as a response back here. It's going into the thinking mode, and we can see, sure enough, one of the key things that this model does is to basically try and make sure that it understands your question. So you will see for a lot of the prompts where people try to trick it with questions about brothers and sisters or trolley car problems and stuff like that, that the thing that sets this apart from a lot of the things out there is it won't necessarily just default to face value of, is this in the training set? Therefore, I will answer the version that's in the training set. If you change these things, the idea is that it should establish out what are the variables, what are the key parts for this, and then sort of restructure it. We can see this here where it's basically doing understand the core question, identify the immediate context, brainstorm the direct consequences, consider the alternatives. So all of these are different kinds of chains of thought. And each of these things, it does seem to me that it's almost setting up to do these chains of thought in a structured way. So where the DeepSeek models tend to have a sort of continuous, just talking to itself chain of thought, these Gemini thinking models tend to be much more sort of structured of as they're going through each of the things. And you can see that we're actually getting numbers for each of the different kinds of chains of thought, and then bullet points basically for subpoints in that. So we can see that it's come up with different options of what might have happened. It then quite consistently will take that chain of thought and synthesize it in some way and structure out an explanation. Now, we saw that with the Tetris game, and we're seeing the same sort of thing here, where you're seeing this synthesize the scenarios, basically going through them, and then structure out an explanation to this. So at this point, we're at sort of chain of thought 6, and then chain of thought 7, I guess, is sort of like the polish or the refined language for us to get out our final answer. Now, this is where I really think that the thinking tokens are often really useful, not just to get to the final answer, but to actually sort of justify or explain the final answer that we get out of here. Now, the really cool thing is both in the consumer app, we get those thinking tokens and in the AI Studio. But unfortunately, when we come into the API, currently we're not getting any of that out. You can see that when we ask the API basically to give its thinking out, we're actually getting the thought equals none in here. So I really hope that for the general release, that we are going to be able to get access to these thinking tokens, just like Anthropic is giving them and just DeepSeek, etc., is giving them. Okay, so just to finish up, because I kind of feel like you should come in here and try your own prompts to see how it's going to go, rather than me go through a bunch of standard tests, etc. But this one I thought was really kind of interesting. So if we ask it, give me 10 really hard thinking problems for an LLM. So sure enough, it can go through and give us 10. But what I find fascinating in here, again, that the thoughts and sort of like a lot of the key parts of this is that, again, it's sort of going through this whole process of sort of restating the question or understanding the question, in this case, understanding the goal for this. But then two, it's understood that it needs to identify LLM weaknesses and challenges. And here, sure enough, it is really getting at the sort of core underlying things that are going on with these models and where they actually fail a lot. The whole sorts of things of physical intuition and simulation, right? A lot of questions out there are still doing this. Now, I'm not saying that this model is perfect at all these things, but the fact that it kind of knows where things are going wrong does show that the training data has kind of pushed it in a really nice way to sort of think about these things. We've got things like novel concept synthesis, planning, right? Long range planning and strategy. You've got to think that this model is going to do really well for agents if it can identify what's going on with these things and actually use them. Ethical nuances. So all the sort of trolley problem sort of tricks and stuff like that, you can see that it's kind of geared for this kind of stuff just by doing these things. Metacognition, self-awareness, a variety of these different things. And then it goes on to basically try and brainstorm out some things for this to actually get to my answer. The thing that I find really fascinating here, though, is the thinking tokens are actually far more interesting in showing us how the model is actually working than the final answers out. And this is why I really hope that Google does open up so that we can get access to these thought tokens via the API. Because you can imagine this is going to help for doing a variety of different tasks with users if you can kind of be able to show them some of the reasoning of why an LLM gave them a particular answer or something like that in here. Again, we can see it's sticking to the structure of where it basically goes through, it does the thinking, it then does this enhancing, and it then does the sort of preparation to give the final answer. In this case, it's actually adding a disclaimer in there and then giving a final polish, check for grammar, spelling, clarity, etc. And then it goes through and actually gives us out the answers and why it's hard for these. So overall, to finish up, this really is a very impressive model. It really is showing signs of being able to do things that other models haven't been able to do. And it's showing that when we do use more test time compute with these longer chain of thoughts, and I would also say in this case, structured chain of thoughts, you're able to get really high quality outputs for a variety of different tasks and problems. And this is where the latest generation of LLMs are going, right? They're going to be multimodal. They're going to have all those sorts of capabilities, but they're also going to get a lot better at the reasoning and thinking and explanation of that, which you've got to think is going to empower a whole new suite of LLM apps and obviously agents and getting these things to be able to automatically do different tasks for us. So I'll certainly be using this to put it through its paces for some agent stuff. Look out for that over the next couple of weeks. Don't forget that this is just the experimental version of it, so it's probably still going to even get substantially better from here before it goes to the GA version. But hopefully this is going to be in Vertex pretty soon, where we're not going to be as constrained by the quota that you are on AI Studio at the moment. So I'd love to hear from you in the comments. What have you tried it for? Check it out. Love to know, especially sort of what's not working. I think in some ways that's going to be more interesting than what specifically is working. Obviously, every time they change doing the training of these systems, you're always risking sort of making it dumber in some particular area. And the key thing is to identify that when it's an experimental model so that they can update it before it goes to the general release. Anyway, as always, if you like the video, please click like and subscribe, and I will talk to you in the next video. Bye for now.